Yeah, I welcome you back to this amazing channel. So today, by God's grace, we'll be looking at qualitative analysis. Yeah, with respect to WAEC, GCE, NACO. This will really help, most especially in the area that has to do with the second question in chemistry practicals. So we have the qualitative inorganic analysis in this part. So now this analysis is actually used to identify anions, and when we say anions, it means the acid radicals, and also cations. Okay, we use this inorganic analysis to identify cations, that is the basic metallic radicals in a sample. Okay, in a sample salt or mixture of salts. So it could be a mixture of salts where we actually decide what should be the anion and cation, or it could be a mixture of salts or a single salt. Now, firstly, we need to know that the following gases could be asked to be identified, okay, in qualitative analysis, which is also known as the salt analysis. The first one is the chlorine gas. You may be asked to identify chlorine gas. You may also be asked to identify bromine gas. You may be asked to identify iodine gas. You may be asked to identify, carbon monoxide gas. You may also be carbon dioxide rather. You may also be asked to identify sulfur dioxide. You may be asked to identify hydrogen sulfide. You may be asked to identify nitrogen, for oxide. You may also be asked to identify the hydrochloric acid or hydrogen chloride gas. You may also be asked to identify hydrogen bromide. Then you may also be asked to identify hydrogen gas, oxygen, and water vapor. So these are the gases you may likely be asked to identify in the inference when it has to do with qualitative inorganic analysis. Okay, so aside gas, anions can also be asked. You might also be asked to identify anions. So in the course of the exam, the following are the anions, and when we say anions, it means the acid radicals. Okay, so the acid radicals that could be asked to identify in this exam, first is the trioxocarbonate 4. Okay, is a radical. Then the hydrogen trioxocarbonate 4 is also a radical that you could be asked to identify. Then trioxosulfate 6 could also be asked to identify thiosulfate, sulfide ion. Okay, right, so sulfide ion you might also be asked to identify. Then diazonitrate 3 you may be asked to identify. Then also triazonitrate 5 you may be asked to identify that cation. Chloride you may be asked to identify bromide and the iodide ions. Okay, so and lastly, the anions which you may be asked to identify is tetraoxosulfate 6 ion. So these are the acid radicals that you may be asked to identify in the course of salt analysis. Also, as we can be asked to identify gases, then we may be asked to identify these acid radicals, which are the anions. We may also be asked to identify the following cations, okay, which is also the basic metallic radicals. So the following basic metallic radicals could be asked to identify. The first one is the calcium ion. You may be asked to identify that. You may also be asked to identify zinc ion, sodium ion, zinc ion repeated, then copper 2 ion, aluminum ion, lead ion, ion 2, ion 3, potassium ion, and also ammonium ion. Okay, is those salt analysis that has to do with that. Now we want to classify gases. So gases can be classified into three actually. The first one is the acidic gas, okay, and the second type of gas is the basic or alkaline gas. You must be able to give example of each and every one of them. And the third type of gas is the neutral gas or gases. Okay, so example of the acidic gases, we have the carbon dioxide gas, we have the sulfur dioxide gas, that is sulfur 4 oxide gas. Then we also have hydrogen sulfide gas, we have nitrogen 4 oxide gas, and hydrochloric acid gas. Those are the gases that are acidic among those gases that we could be asked to identify. Then we have the basic or alkaline gas, and the only alkaline gas is the ammonia gas, okay, which you may be asked to identify. Then we also have the neutral gases. The neutral gases which you may be asked to identify is your oxygen gas, hydrogen gas, and then water vapor. So these are gases you could be asked to identify in salt analysis. Now we want to look at the characteristic features of each of these gases. We look at their color, their odor, and their action on litmus. For the first one, which is carbon 4 oxide, it is a colorless gas. Okay, carbon 4 oxide actually is a colorless gas. It is odorless, and at the same time on litmus paper it turns red. Okay, it turns red. Okay, then is a weakly acidic gas. This gas here is actually a weakly acidic gas. Then similarly, sulfur 4 oxide is also a colorless gas, but it has an irritating, it has an irritating odor, smell, and also turns red, which means it's also acidic. Okay, so both sulfur 4 oxide and carbon 4 oxide are, acidic, but weakly acidic precisely. Okay, they are weakly acidic in nature. Now we have the hydrogen sulfide gas. It is also colorless. It has no color, but has the smell of a rotten egg. Okay, not that. Hydrogen sulfide gas has the smell of a rotten egg, which could be irritating, then turns red. Okay, which means it is also acidic. It turns blue litmus red. Now we have the nitrogen 4 oxide. His own color is reddish brown. Okay, it is reddish brown. It has an irritating smell or odor. It also turns red, which means it is acidic as well. So the first 1, 2, 3, 4 are acidic gases. Okay, the nitrogen chloride gas happens to be colorless with an irritating smell, okay, and turns red, so which means it's also acidic. Then we have chlorine gas that is greenish yellow. That is its own color. Chlorine gas is greenish yellow. It is also irritating. It has irritating smell. then turns red, and then bleach. It turns red and then bleaches. All right, the same thing as bromine gas. Bromine gas also turns blue litmus red and then bleaches it. So for bromine gas, its own color that makes it different from chlorine gas is it is reddish brown. Okay, it is reddish brown and also has irritating smell like chlorine gas, turn red and then bleaches. Okay, so we have the iodine gas. It has a purple or violet color. It is irritating, okay, and then turns red. Ammonia gas is colorless. Ammonia gas doesn't have any color, but has a choking, an irritating smell. Okay, like the smell of a dead rat. So it turns blue. Okay, it turns blue. It turns red litmus blue. So it is the only and the most common alkaline gas. Then we have the oxygen gas, which happens to be colorless, odorless, and it is actually neutral to litmus. It has no action on litmus paper. The same thing as hydrogen gas. This is oxygen gas. This is hydrogen gas. Hydrogen gas is also colorless. It is odorless. It has no any effects on litmus paper as well, which means it is neutral. Then we have vapor. Okay, the vapor is also colorless. It is odorless. It has no action on litmus paper. So those are the characteristic features of the gases that you may be asked to identify. So it is quite essential for you to know them. Okay, so now we want to look at preliminary test for each of those gas. So we want to test for, how do we test for the presence of carbon dioxide or the this is trioxo carbonate 4 ion, trioxo. Okay, so how do we test for the presence of this or the bicarbonate, hydrogen trioxocarbonate 4 or trioxo carbonate 4 or carbon 4 oxide? How do we test for that? How do we test for them? So now for the carbon dioxide gas, it's actually evolved, meaning given out when sort of when any sort of trioxocarbonate 4 or salt of hydrogen trioxocarbonate 4 are heated or reacted with dilute acid. When the salt of this or these are heated, like when you heat sodium trioxocarbonate 4 or sodium hydrogen trioxocarbonate 4, then carbon 4 oxide will be liberated, emitted. Okay, so what will be the observation? So you check what you will observe after you have heated a salt of this, or you reacted a salt of this with this. Then you look for the features of carbon dioxide, meaning you will experience or observe a gas that is colorless, odorless, and turns red. Okay, so now it is quite essential for us to also know, apart from the above characteristics given in the table, that you should know that carbon dioxide, carbon 4 oxide, extinguishes burning split. So it extinguishes, it kills a burning fire. Then also, what you should know about them again is that they turn lime water to become milky. Okay, they turn lime water milky. The next is, how do we test for sulfur 4 oxide? Okay, so now to test for sulfur 4 oxide, it is actually liberated when triosulfate or tetrasulfate 6 or thiosulfate salts are heated. Okay, when thiosulfate salts, tetrasulfate sea salt are heated, or when they react with acid, when they are treated with acid, then SO4 will be liberated. So what do you observe when the gas is liberated? You will observe a gas that is colorless, okay, that is colorless but irritating smell and turns red, okay, on reaction with litmus paper. So when you check the table, you see your observation, okay. Then we are asked to note that sulfur 4 oxide decolorizes KMnO4, okay. Sulfur 4 oxide actually decolorizes KMnO4 from its initial color, which was blue, okay, or sorry, purple rather, and make it become colorless. So SO2 decolorizes, sulfur for KMnO4. So which means sulfur 4 oxide changes the color also of potassium heptaoxotichromate 6, K2CR2O7. So the initial color of this is yellow. So it changes this from yellow then to green. Okay, so SO2 does that, which means that SO2 is a reducing agent. Okay, this potassium heptaoxodichromate and potassium tetraoxomanganate 7 are oxidizing agents. So this is a reducing agent. It reduces them. That is actually for sulfur 4 oxide. Then next is how do we test for hydrogen sulfide? How do we test for hydrogen sulfide? So it is actually yielded, it is produced when dilute hydrochloric acid or dilute triazonitrate 5 acid is heated with sulfide salts, okay, e.g. hydrogen sulfide. So when you heat hydrogen sulfide in the presence of hydrochloric acid or HNO3, then hydrogen sulfide will be liberated. So you see the feature of hydrogen sulfide as explained in the table above. Okay, we said earlier that hydrogen sulfide is also colorless, that has the smell of a rotten egg and turns blue litmus red. So now, further important or further notice, what you need to know as well about hydrogen sulfide is that it decolorizes KMnO4 and changes the color of K2CR2O7 from yellow to green, like the SO2 will do, and also turns paper soaked with either lead triazonitrate 5 or lead acetate black. Okay, it actually turns the paper soaked with this or this, it turns them to black. So now note to distinguish between this and this, sulfur 4 oxide and hydrogen sulfide, we should note that both are reducing agents. So to distinguish actually between them, use lead nitrate or you use lead acetate to distinguish between SO2 and H2. So SO2 has no effect on lead salts, okay, be it lead acetate or lead be it lead acetate or lead nitrate. Now next is how do we test for nitrogen 4 oxide. As for nitrogen 4 oxide, it is actually liberated when a salt of heavy metal, okay, when salt of heavy metals are heated by the action of conc H2SO4, okay, on any of these salts. So when a salt of heavy metal is heated, when a salt of heavy metal is heated, that is the salt of any of the triazonitrate 4 is heated with heavy metals. Then you will see also being, when you check the table above, you will see what will happen when the salt of this is heated with heavy metals. The next is hydrochloric acid. As for hydrochloric acid gas or hydrogen chloride gas, it is actually liberated when conc H2SO4 is heated with a chloride salt. Okay, so when you check the table above, you see the features of what will happen after conc H2SO4 acid is heated with a chloride salt. Then we are asked to notice that a dense white film of ammonium chloride is formed. Okay, of ammonium chloride is formed when a paper soaked in a conc ammonia solution, okay, is treated with that. Then also silver nitrate can also be used to confirm HCl. Very essential for you to note that. Then how do we test for chlorine gas? Chlorine gas is actually formed also when hydrochloric acid, okay, is added to a mixture of a salt, okay, of a chloride salt and manganese 4 oxide powder. So what do you observe is also present in the table. Check the table above for the feature of Cl2 gas. When you check the table, you see the feature of chlorine gas. Okay, now, but we have to note that introduce into the glass strip of starch paper soaked in potassium iodide, the paper turn blue black. That is how you observe, that is the observation, that is how you will observe that chlorine gas has been formed. Now, ammonia gas is yielded when ammonium salt is heated or treated, okay, is yielded or treated with an alkali. When it is treated with an alkali, okay, so we all know that it is the only alkaline gas and has a pungent or the smell of a rotten rat. So now how they ask us to note a dense white film. Okay, conc HCl forms a dense white film with ammonium chloride. All right, so that is how to test for that. As for steam is actually produced, okay, when hydrogen salt is heated. It condenses at the upper or the cooler part of a test tube. Okay, so we already know that steam is a colorless, odorless, and has no action on litmus paper. Okay, so when you check the 3 mode of testing water that we already explained in some of our classes, you know how to confirm, okay, water, how to confirm the presence of steam or water. Okay, so we use this salt. Copper sulfate changes from white to blue in the presence of water. This changes from white to colorless in the presence of water. This changes from blue to pink in the presence of water. Okay, so now test for oxygen gas. How do we test for oxygen gas? So oxygen gas is given off when potassium nitrate or potassium triazonitrate 4 or sodium triazonate, potassium triazonitrate 5 or sodium triazonitrate 5 or hydrogen peroxide or potassium triazochlorate 5 is heated. When any of these are heated, oxygen gas will be liberated. So we already know that oxygen gas is a colorless, odorless gas, okay, and has no action on litmus. How do you confirm that oxygen gas has been formed? It is it rekindle a glowing split. Okay, it rekindle a glowing split, shows the presence. So when a splint, continue, burning, and oxygen gas is actually observed. So now hydrogen gas. How do we test for hydrogen gas? Okay, how do we test for hydrogen gas? Hydrogen gas is actually evolved when HCl is treated with reactive metal. Okay, so when HCl is treated with reactive metals, hydrogen gas will be liberated. Then we already know the feature of hydrogen gas is also a neutral gas that is odorless and colorless. But meanwhile, to confirm, it burns with a characteristic POP sound, which squeeze keep up. Now next is how to identify acid radicals and anion. So we have two ways of identifying acid radicals. First one is the dry test, and the dry test actually divided into three. You can use heat, we can actually use action of dilute acid, or we use action on conc H2SO4. Now we have the wet test, which is like the wet test that has to do with heating or the like or solution. Okay, so it is very important we note this. Now this also divided into two: the use of precipitating agent or the use of oxidizing agent. So this part is very essential. The wet test, they concentrate for the past years, they've been concentrating their questions on this part. So now, what are the common precipitating agents that are used in identification of acid radical? So the common ones they use is the silver nitrate. They also use barium chloride, very common. They use lead nitrate or lead acetate. They also use magnesium sulfate. They use potassium permanganate. Okay, they also use iron 3 chloride, and so on. Okay, and so on. So in place of barium chloride, barium nitrate may also be used. Okay, all are aqueous. All these solutions are aqueous. Now, what will silver nitrate precipitate? Whenever silver nitrate is used for you in the exam, note that silver nitrate will precipitate trioxocarbonate 4. It will precipitate sulfate 6. It will also precipitate sulfide ion, chloride ion, bromide or iodide ion. Those are what silver nitrate will precipitate. Then similarly, what will barium chloride or barium nitrate actually precipitates? So you have to note as a student that barium nitrate will precipitate trioxocarbonate 4, trioxosulfate 6, sulfide ion, and tetraoxosulfate 6 ion. Please, let's make sure we commit these parts to memory. It is quite very essential we note that part, what and what they would precipitate. We should know what those solutions, the precipitating agent, what they will precipitate. And what would lead nitrate or lead acetate precipitate? Lead nitrate will also precipitate this CO32 negative, SO32 negative, sulfide ion, chloride ion, then also iodide ion is going to precipitate that. So these first three are the most common one that has been using for years. But meanwhile, what will magnesium sulfate precipitate? Magnesium sulfate will precipitate trioxocarbonate 4 ion in solution. Then what would potassium permanganate or potassium tetraoxomanganate 7 precipitates? It will precipitate this in solution. What will iron 3 precipitate? It's going to precipitate this. So let's put that into consideration. Now, what are the result and observation on using lead nitrate? So when we use lead nitrate what we observe, we have known what lead nitrate will precipitate. It's going to precipitate, this, and this. So what will happen when it precipitates them? It forms a white or brown precipitate. Okay, it forms a white or brown precipitate in solution. Okay, in excess dilute nitric acid. Okay, white or brown precipitate shows soluble in excess. White or brown precipitate soluble in excess. Okay, shows the presence of, shows the presence of triazocarbonate 4, triazosulfate 5, and also sulfide ion when you see white or brown precipitates. So note that this will be seen. Then if it is just a white precipitate which is insoluble in HNO3, so it shows the presence of chloride ion, insoluble in HNO3. But if the color is yellowish white, okay, a yellowish white precipitate insoluble in HNO3 indicates the presence of Br minus, a yellowish white, okay, precipitate, and it is insoluble in HNO3 indicates the presence of Br minus. So now if the reaction is not visible, okay, if the reaction does not go at all or no precipitate, so what happened? It shows that CO32 minus, SO32 minus sulfide and the halides. Okay, so that is when there is no visible reaction. Then what are the observations when we have barium chloride or barium nitrate? So barium nitrate and or barium chloride, what do they form? So you will form you're gonna see a white precipitate insoluble in dilute HCl or HNO3, and indicates, so that will indicate CO32 minus, then SO32 minus, or sulfide ion S2 minus. That is if you see a white precipitate that is insoluble in that. Then similarly, a white precipitate, for the first one, white precipitate soluble rather. Then for the second one, a white precipitate insoluble in dilute HCl or HNO3 confirms the presence of SO42 minus. So when there is no visible reaction, okay, when there is no visible reaction or no precipitate, it means that CO32 negative, SO32 negative, S2 negative, or tetrazosulfate 6 ion. Okay, that is if there is no reaction at all. If there is no reaction at all. So what will be our observation using lead acetate or lead nitrate? Very, very important. So lead acetate, okay, so if there is a white precipitate that is soluble on warming and reappears on cooling, okay, that confirms Cl negative. Okay, but meanwhile, if a white precipitate which is insoluble on heating, okay, a white precipitate which is insoluble on heating shows the presence of SO32 negative, SO32 negative, CO32 negative, and SO42 negative. Okay, now if we have a black precipitate that confirms the presence of S2 negative, then we know that sulfide is present. And if no visible reaction or no precipitate shows CO3, SO32 minus, and SO42 minus of chloride ion, would be present. Okay, now what is the result and observation using KMNO4? As for KMNO4, there will be an immediate decolorization, okay, of purple color of KMNO4 solution, and then a reducing reagent is present, that is SO3 2 minus are present. And if there is no reaction or no color changes, okay, and the solution remain purple, then the reducing agent will say it is actually absent. Then what will happen on using iron 3 chloride? So if there is a change in yellow to wine red, then to colorless on warming, then the reducing agent is likely. Okay, so that is how you identify the wet test for acid radical. So on the identification of basic metallic radical, now basic metallic radical, that is the cation. So basic examination, what do we observe, or what reagent do we use in observing? Now first one is appearance test. Now if the substance is crystalline or powdered and white, and its solution in water is colorless, the solution in water is colorless, then transition metals are absent, because transition metals are always colored. Now if the substance is crystalline or powdered, or its solution in water or dilutes HCl is colored, then transition metals are present. Okay, if they are colored, because transition metals are colored. Now if the substance is black, okay, it can be sulfide or a oxide, okay, or a oxide. All right, so now we need to know the colors of this cation. The first one is copper 2. It is actually bluish green. Iron 3 is pale bluish green, that is iron 2 rather, and iron 3 is either brown or yellow. So observation from flame test. So a cation that has a golden yellow, that is the color of sodium for flame test. If it is brick red, that is calcium ion. If it has a light yellowish green, that is barium ion. If it is bluish or dark green, okay, that is copper 2. And if it is lilac, that is potassium ion. And if it is light or pale blue, then we said it is lead 2 ion. So the most important reagents for testing metal ion are very important also: sodium hydroxide and aqueous ammonia or ammonium oxide. Others are hydrogen sulfide, HCl, and HNO3. So test using sodium hydroxide now, very important. To a 1 cm cube of the substance, add sodium hydroxide in drops by drop. If precipitate is formed, then add in excess of sodium hydroxide. So what do you observe? Now if there is a white gelatinous precipitate in drops, which is soluble in Sx, okay, which is soluble in excess sodium hydroxide, so white gelatinous precipitate is formed. So you say it's either zinc ion, lead ion, or aluminium ion. So they are present if there is a white gelatinous precipitate. Meanwhile, if there is a dirty white precipitate, okay, in drops, and then insoluble in excess sodium hydroxide, dirty white gelatinous precipitate, dirty white precipitate rather, then know that is the presence of calcium ion. And if there is a light pale blue precipitate, insoluble in excess, then know that copper 2 ion are present. And if there is a dark green precipitate, insoluble, please make sure you write your precipitate in full. Okay, insoluble in excess sodium hydroxide, then the precipitate turn brown on standing, then you say ion 2 is present, and then oxidizes to ion 3. So very important here. Now if there is a reddish brown precipitate which is insoluble in sodium hydroxide, then know that ion 3 is actually present. Ion 3 is actually present. And also if there is a brown or black precipitate that is insoluble in excess sodium hydroxide, that shows the presence of silver ion. And if there is no precipitate or no visible reaction, but on warming, a gas with choking or irritating smell, okay, which turn red litmus paper blue, is given off, then you know that ammonia gas from ammonium ion is actually present. So that is what we use. That is for cation. Then for test for cation using aqueous ammonia. So to 1 cm cube of the solution of the substance, add aqueous ammonia drop by drop. So if there is precipitate formed, then add excess aqueous ammonia. Now what will be your observation? If there is a white precipitate that is soluble in excess sodium hydroxide, white precipitate soluble in excess sodium hydroxide, then zinc ion is present. Okay, but meanwhile, if there is a white gelatinous precipitate that is insoluble, the first one is soluble in excess and the second one insoluble in excess, and it's also white, then what you observe is lead, okay, ion or aluminium ion, okay, will be present. But meanwhile, if there is a light or pale blue precipitate, okay, soluble in excess ammonia and gives a blue solution, then know that copper 2 ion is present. If there is a dirty green precipitate insoluble in excess ammonia, ion 2 ion will be present. If there is a reddish brown, okay, insoluble in excess ammonia, then just know that ion 3 ion is present. Then if there is no precipitate whatsoever at all, calcium ion, barium ion, sodium ion, or potassium ion, okay, are likely to be present. So now those are the summary of what we need to know about